Alright, welcome to the last video for Chapter 5. We're going to deal with that Section 5.5, Day 2. And it's solving trig equations using factoring. So we're going to solve each on the interval of 0 to 2 pi. Alright, remember from yesterday a couple of things. First of all, remember that sine has a period of 2 pi, cosine has a period of 2 pi, tangent has a period of pi. Okay? The other thing, remember, you can do. If this looks too much with the sines, you can always come over to the side and ask yourself, how would I factor this? Okay? So, I'm going to go ahead and zoom out for just a little bit. Remember when we factored these with a lead, one method you had was guess and check. The other method was to go ahead and do the big T. So you would multiply 2 times 1 and you get 2x squared negative 3x. And you say, what multiplies to give me 2 and adds to give me 3? Oh, 2 and 1. Now you came down here and you took out the 3. And you put in, now for these to give me a negative 3, I need a negative 2x and a negative 1x. Now do you remember that we grouped? We said, hey, what do these guys have in common? Oh, they have a 2x. What do these have in common? They have a 1, but remember we never let it lead with a negative, so we're going to pull that out and I get x minus 1. Your check comes right here because the parentheses have to be the same. So I get 2x minus 1, x minus 1. Okay. Let's take all this hard work we did here and bring it back over here. So really I have 2 sine x minus 1 times sine x minus 1 equals 0. Alright, so we do all our work over here, now we apply it. Now, if you were solving this, what would you do at this point? Oh, you'd pull them apart and you'd do 2x minus 1 equals 0, x minus 1 equals 0. So we're going to do the same thing here. Let's pull them apart. And I get 2 sine x minus 1 equals 0. Sine x minus 1 equals 0. Okay, so let's go ahead and find this one. So to solve this equation, I'm going to first add 1. So I get 2 sine x equals 1. Alright, so to get sine by himself, we're going to go ahead and divide by 2. So I get the sine of x equals 1/2. Now we're back to what you learned yesterday. So we're going to take the inverse sine of both sides. Now, remember, this leads you again to 2 paths, right? So first of all, find me the type of angle that gives me 1/2. So sine of 1/2 is a pi over 6 angle. So I could truly be a pi over 6. Or, where else is sine positive? Sine is positive in quadrant 2, so I could also be a 5 pi over 6. Alright, but don't be lazy. Go ahead and finish it up for me and give me the plus 2 pi n. Okay? Now I need to see what this guy gives me. So I'm going to go ahead and add 1. So I need the sine of x to be 1. I take the inverse sine of both sides, and I get x equals. So I look at my chart. Here's my 1. It's a pi over 2. Now, that one's a weird guy, because you think he should give you 2 answers, right? They normally do. But this one's only going to give me pi over 2. Because, think about it. Where else, if you look at your wagon wheel, where else is sine 1? Nowhere. Here it's 0, here it's 0, here it's negative 1. So this would be pi over 2 plus 2 pi n. So my solutions would be pi over 6, 5 pi over 6, and pi over 2. Because again, anytime I add that 2 pi in, guess what? I go right over 2 pi. Alright? Okay, let's try the next one. Let's say I have 4 cosine squared x minus 3 equals 0. So again, if I'm stuck, which a lot of times we will get stuck, come over here to the side and ask yourself, how would you solve this? Well, the way I'd solve it is I'd go ahead and move the 3 over. So I'd get 4x squared equals 3. Then I'd divide by 4. So I'd have x squared equals 3/4. And then to get rid of the squared, I'd take a square root. So my answer would be x is equal to positive or negative square root of 3 over 2. Alright, let's come over here and apply that same thing. So first thing I did was I added 3. So 4 cosine squared x equals 3. So I divide both sides by 4. I get cosine x squared is equal to 3/4. Take a square root of each side, and I get that the cosine of x is equal to positive or negative square root of 3 over 2. Alright, let's first deal with the cosine of x is equal to the positive square root of 3 over 2. And then I'm going to do the cosine of x is equal to the negative square root of 3 over 2. This one's going to lead me to possible solutions. He'll give me 2 possible solutions. So I want to just make sure you understood why I went ahead and separated it. Mainly it's to keep myself straight. Because this guy's going to give me 2. If I keep it all together, I got to remember that he's going to give me 4. Alright, so let's take the inverse cosine. Alright, so a cosine square root of 3 over 2 is a pi over 6 angle. So one possibility, since he's positive, is that he is pi over 6. Or, where else is cosine positive? Quadrant 4, so he could potentially be an 11 pi over 6. He's cosine. What's my period? 2 pi n plus 2 pi n. Alright, let me deal with this guy now. So, for him to be negative, that means that I would either be in quadrant, let's see if I take the inverse cosine, I have to either be in quadrant 2, which makes him a 5 pi over 6, or I could be in quadrant 3. Alright, again, I can ignore the 2 pi's. They're just going to send me further than I need to be, because I've already limited your, so it's going to be pi over 6, 11 pi over 6, 5 pi over 6, and 7 pi over 6. Now, the book, I think, gives them in order. I'm okay, you know, whatever works for you. Okay, let's try one more. and then we're going to talk about what to do when you're going to need to use your double angles and things like that. So let's say I have sine x tangent x minus sine x equals 0. Okay, so if you're stuck, you could come over here and write xy minus x equals 0 and say, how would I do that? Well, I'd factor out an x. So here, can I factor out a sine? Now, I believe this I can go ahead and separate. So I have the sine x equals 0, or tangent minus 1 equals 0. Now realize, he's going to give me 2 potential. He could possibly give me 2 potential. So I want to take the inverse sine of both sides. So I get x is equal to, I need to know where is sine negative, or sine 0. Okay, sine 0 is at 0. But now let me look down here at the unit circle, because that's one of those weird ones. Remember, 0 or 90 could potentially result in more choices. So I agree, the sine is 0 at 0. It's also 0 at pi. So he could be 0, or he could be pi, plus 2 pi n plus 2 pi n. Alright, so those are his solutions. Now let's see what this guy will lead us to bring. I'm going to kind of scooch him over a little bit so I have some room. So do you agree that it's the tangent of x is equal to 1? So now I take the inverse tangent of both sides. He's going to lead me 2. Alright, so the tangent is 1 when I have a pi over 4. And I'm positive, so I could be a pi over 4, or where else is tangent positive? In quadrant 3, so he could be a 5 pi over 4. Now, tangent, remember, is plus pi n, plus pi n. Alright, so let's write them down. 0, pi. I don't need to worry about those 2 pi's, but over here I do need to. So I get pi over 4. So 1/4 plus 1 is 5/4. And again, remember I told you, tangent, you really don't have to do this one. That's all you have to do and you'd be able to get the solution. For me, though, I just get all confused when I start switching things up, so I just like to keep them separate. Or to do the tangent exactly like I do everybody else. Alright, let's keep moving on. So those were the first type, when everything was all set up for you. But what happens when you get weird stuff? Like this. And at first, you're like, well, I don't know. But I do believe, now, go back to when we were doing identities. The reason I can't ignore this 2 is because he doesn't have one. So I just can't ignore it or make a substitution. But I believe he's a double angle formula, isn't he? Isn't cosine 2 theta any of these? So you pick the one that makes the most sense to you. But we need to be a little bit smart when we pick. Look what we're dealing with. We also have a sine. So I probably want to pick something that's going to give me just sines. So I'm not so happy about that because that's going to give me a cosine squared. That would be like doing an x and a y in one problem. Okay, I'm not too happy with him again because he's got the cosine squared. But look, if I do this, I get sines. So I get everything on this side is going to be in terms of sines. That's a good thing. So I'm going to actually replace cosine 2x with 1 minus 2 sine squared x plus sine x equals 0. Okay, once again, the reason I chose this formula is because it got everything now in terms of sines. So I'm going to write this as negative 2 sine squared x plus sine x plus 1 equals 0. I just rewrote its order. Remember back from Algebra 1, we said we never like leading with a negative. So I can change everybody's sign. Okay. Again, pull him off to the side. So you have 2x squared minus x minus 1 equals 0. And let's factor that. So I do 2 times 1 is 2x squared, and that's really a negative 2x squared. This guy goes at the bottom. Now, if you think you know how to factor, I'd like you to go ahead and hit pause and try factoring it. So for those of us who need to be walked through it, I need factors of 2 that subtract to give me 1. Ah, it's 1 and 2. Now think about it. I need this to be a negative 1. So I'm going to let him be positive and him be negative. So I come back over here to this original problem. I take out positive or negative x and I put in a 1x and a 2x. And now I can group. Alright, so I'm going to come over and try to apply that. Actually, you know what? Let's just stay here. That's fine. So what did this first term have in common? They have an x. So I get 2x plus 1. And this one has a negative 2x plus 1. So life is good. They match. Uh-oh, they do not match. What did I do? Oh, I guess. Please correct your note. Daydreaming. So I get x minus 1, 2x plus 1. Alright, so we come back over here and say, you know what, this really is sine x minus 1, 2 sine x plus 1 equals 0. Now I'm going to go ahead and separate this into 2 pieces. I have sine x minus 1 equals 0, or, and I'm going to kind of spread mine out pretty far, because I know that each one could potentially result in 2 additional answers. So I'm going to solve him first. So I get sine x equals 1. So 1 is at pi over 2, so you need to be careful that there's one of him or 2 of him. So you come down to the unit circle, and I know that the only place sine is 1 is at pi over 2. Plus 2 pi n. So he only had one answer. And the way I found that, again, is I was taking an inverse sine. So let's solve this one a little more involved. The first thing I'm going to do is subtract my 1. So I get 2 sine x equals negative 1. Divide everybody by 2. So I get the sine of x is equal to negative 1/2. Now I take the inverse sine. Go to my little chart. 1/2 is your pi over 6. But he's negative. So I know I have to be in quadrant 3 or quadrant 4. So I'm looking for a pi over 6 in these quadrants. So it is possible that I would be a 7 pi over 6, or I could possibly be an 11 pi over 6. Okay, it's sine, so it's plus 2 pi n. So now I go ahead and I gather all my answers. So this first guy has a pi over 2 to give me. Anytime I added 2 pi, I go over my range. This guy's got a 7 pi over 6 and an 11 pi over 6. And those are my answers. Okay, so it's combining the 2 things together. Alright. I'm going to see, the video might go about a minute longer than usual. I want to at least try to get number 5 done. So this one's going to be a little bit tricky, because right now you can't solve it right? They don't have a GCF to counter out each other. So I'm going to try to make him look like one of our special formulas. So I'm going to work a little bit backwards. I'm going to say, well, you know what if I multiplied this guy by 2? Because as soon as I do that, this formula ought to be saying, well, hello, I happen to be somebody special. What is 2 sine x cosine x? Sine of 2x. So really I can replace this with the sine of 2x equals -1. Now we're in business, because this I can take care of, because it doesn't have a sine and a cosine. So now I can take the inverse sine and the inverse sine, and I get 2x equals, so I need to know where is the inverse sine -1. So I'm going to look at my unit circle right there at 3 pi over 2 plus 2 pi n, yes? So I'm almost done. I'm going to divide everybody by 2. So I get x is equal to 3 pi over 4 plus pi n. Now, is there anywhere else on the wagon wheel where you could potentially be, right? Because normally we get 2 answers, but in this case, no, there's only 1 spot. So, let's make sure we've got everything. 3 pi over 4, but this time, if I add a pi to it, do I say under? Well, let me check. Alright, so 3/4 plus 1. I am under. So there is another solution at 7 pi over 4. Alright, so we will pick this up more tomorrow. You guys have a great evening.